In this video, we're going to start using vector equations of lines in a couple different ways. So with a quick review, the vector equation of a line is r equals a plus tb. We know that r, a, and b are all vector positions for different aspects in relation to this line. So a is going to be the vector position for a point on the line, and b is going to be a vector that is parallel to the line that we are discussing. And finally, r is going to be the position vector of any point on the line. So any point, whether that is point B, point A, whether that is another point, it's going to be some point on the line. All right, so one way that we can use this is to determine if a point is on the line. So is 5, negative 2 on the line 5, 1 plus t for negative 3? So, well, if we want to know if this is on the line, then the value of 5, negative 2 should satisfy this equation. So we're just going to plug that right into the equation. So we get 5, negative 2 equals 5, 1 plus t for negative 3. Okay, so now we're just going to do some basic arithmetic and move our 5, 1 on the other side, subtract it from both sides. We get 0, negative 3 equals t times 4, negative 3. Alright, so now we're going to solve for t. So 0 equals 4t, therefore t equals 0. And negative 3 equals negative 3t, therefore t equals 1. Well, because t is not the same, then we can assume that 5, negative 2 is not on the line. And that should make sense, because t is going to be a scalar, and for all of this to be balanced, all this to be equal, then t should be the same for both aspects, for both the x value and the y value as we're solving for this. So to find one that is the same, then our t values would be equal. Okay, so since it's not the same, t is not the same, then we know that the point is not on the line. Let's look at another way that we could apply this. So where do the two lines r1 are equaling 3, 0, negative 1 plus s 1, 1, 1 and r2 6, 2, 0 plus t 0, 4, 8 meet? Okay, so we need to find where these two things meet. Now we don't know the point where r1 or r2 meet. So we're going to create a general point. We'll say x, y, and z, and we're going to plug that into both of our equations in place of r1 and in place of r2. Because if these things meet, then they should be the same for both vectors. So let's solve for our x, y, and z. So we get x equals 3 plus s for our r1, y equals s, and z equals negative 1 plus s. And then for r2, we get x equals 6 plus 0t, y equals 2 plus 4t, and z equals 8t. Alright, so we've got a lot of variables in here, a lot of unknowns. So we want to try and set some of these things equal to each other so we can find some of these unknowns. So let's start by putting our x's equal to each other. So we get 3 plus s equals 6, and s obviously equals 3. Alright, so now let's look at how we can use maybe 3 with some of our other unknowns, with our y and our z. So with our y, we have s equals 2 plus 4t, right? We're just setting both of these y's equal to each other. Well, we already know what s is, so we can plug that right in. So we've got 3 equals 2 plus 4t, and 4t equals 1, therefore t equals 1/4. Alright, so now we want to look at our last equation. We're going to look at the last point. We're going to look at z. And we're going to plug in, we're going to set these two things equal to each other as well. So we get negative 1 plus s equals 8t. Well, let's use s again, and we'll plug it into the equation. And we get negative 1 plus 3 equals 8t, and we can see that 8t is going to equal 1/4. Okay, so because we've used s and we've gotten the same values for t for multiple points, we can assume that these two things are going to be equal. So what we'll do is we'll find where R1 and where R2 meet. So we're going to use S for our R1, right? We're going to plug in the value that we found for S, which is 3, and we just solved for R1, and we get the 0.632. Now T, we know that's going to be 1/4 for R2, so we plug that in, and we set the, and don't set them equal, but we solve for R2. And R2 is going to also equal 632, so we know that these two things meet, these two vectors meet at that position. So that's two ways that we can use vector equations of lines to help us find either if a point is on the line or where they meet. And there's a couple other applications that we could do as well, and we'll talk about those maybe in some other videos. Hope this helped.